Hello everybody, welcome to Embetronics. We have provided the Linux device driver tutorials on our website embetronics.com. Many of our website users have been asking us for a long time to provide a video tutorial for the Linux device driver. That's why we are here. Please support us and motivate us to do our job better. As this is the very first part, we will see the introduction of the Linux device driver. In this video, we will see the introduction, Linux architecture, Linux kernel module, device driver and its types. What is Linux? Linux is a well-known and most used open source operating system based on Unix. This has been created by Linus Torvalds on September 17, 1991. Who is peeping at the left bottom corner? Oh, hey Linus Torvalds. We are talking about you and your wonderful creation only. We are here to learn your Linux OS. Let us learn and please don't disturb us now. Thank you. Okay, let's come back to the topic. Users can modify and create variations of the source code known as distributions for computers and other devices. For example, Debian, Fedora, Ubuntu. You know something? Android is also developed on top of the Linux kernel. Okay, let's move to Linux architecture. Linux memory has been divided into two parts. One is kernel space and another one is user space. In the kernel space, kernel, device drivers, kernel modules will run. This kernel can access both user space and kernel space memory. In the user space, normal user processes will run. These processes running under the user space cannot access the kernel memory and have access only to a limited part of memory. User space processes can only access a small part of the kernel via an interface exposed by the kernel called the system calls. So, if the user space application or process wants to access the hardware, then it has to go through the kernel drivers. It can't be able to access directly. Do you know why did they separate these two parts? If some issue happens in the user space application, it should not affect the complete kernel. This is one of the reasons. But if something happens in the kernel driver, then it will reboot the complete system due to the kernel panic. That's why the kernel developer needs to be more careful while developing something. Now, we will focus on kernel space. What are Linux kernel modules? This Linux kernel module is a piece of code that can be loaded and unloaded into the Linux kernel upon demand. They extend the functionality of the Linux kernel without the need to reboot the system. These Linux kernel modules can be added to the Linux kernel in two ways. We can add statically or dynamically. When you add the code to the Linux kernel source tree and recompile the kernel, this kernel module will be part of the kernel now. So, the kernel size will increase. This way is the static method. In this method, you cannot unload this module. You build your kernel module separately, then add that to the running kernel when you need it. This way is the dynamic method. This dynamic method is very efficient because we can load the module when we need it and unload the module when we don't need it. Since we are loading this code at runtime and they are not part of the official Linux kernel, these are called loadable kernel modules, which is different from the base kernel. In our tutorial series, we are going to use this dynamic method only. What are the advantages of the loadable kernel module? One major advantage they have is that we don't need to keep rebuilding the kernel every time we add a new device or if we upgrade an old device. This saves time and also helps in keeping our base kernel error-free. Loadable kernel modules are very flexible in the sense that they can be loaded and unloaded with a single line of command. This helps in saving memory as we load the LKM only when we need them. Device driver. A device driver is a particular form of software application that is designed to enable interaction with the hardware devices. Without the required device driver, the corresponding hardware device fails to work. A device driver usually communicates with the hardware by using the communication subsystem or computer bus where the hardware is connected. Device drivers are operating system specific and hardware dependent. A device driver acts as a translator between the hardware device and the programs or operating system that use it. Let's take the USB device. I have been wasted so many hours with some USB device that doesn't have a USB device driver. If I have had the correct device driver for that USB device, I could have saved few hours in that starting stage of my career. At that time, I don't know about the device driver. So, without the device driver, the hardware may not work. In Linux, everything is a file. Linux treats everything as a file, even a hardware. A device file is an interface for a device driver that appears in the file system. These are usually found under the dev directory. In simple terms, when we write a Linux device driver, it will create a device file, and when you talk to the device file, it means you are actually talking to your device driver. You will understand this easily as we go to the example, so don't worry. In Linux, the device driver is divided into three types: character device driver, block device driver, and network device driver. Let's see the character device driver first. A character device driver is a hardware driver that writes data in character by character fashion. Some classic examples are keyboard, mouse, serial printer. If a user uses a character device file for writing a data, no other user can use the same character device file to write the data that blocks access to another user. In this series, we will be discussing this character device driver only. Block device driver. A block device file is a hardware file that writes data in blocks instead of character by character. This type of file is very much useful when we want to read data in bulk fashion. All our disks such as HDD, USB and CD-ROMs are block devices. Network device driver. A network device is an entity that sends and receives packets of data to the outside of the world through network devices. This is normally physical device such as an Ethernet card, Wi-Fi, Bluetooth device. Okay, we have come to an end of this video. Was it boring? Big yes, right? This looks like classroom teaching, isn't it? I am sure that you will enjoy our next video. Let's be prepared to make your hands dirty. From the next video, we will be getting into the action. I hope you might have understood some basic stuff about Linux in the high-level view. Even if you don't understand also, fine. You will understand it easily when you start working. If you like our content, then please subscribe to us. If you don't like our content, please comment us what you don't like. We will try to improve. We have other tutorials like STM32, bootloader, unit testing in C, 8051, PIC controller, ARM controllers, Raspberry Pi Pico, ESP32, Linux device drivers, RTOS and many more on our website. Please check that too. Thank you. See you with another good tutorial.